So NVIDIA has just had its recent earnings call, and in this video we are going to look at some of the most interesting news, some of the most interesting takeaways. And since the earnings call, we have actually seen NVIDIA jump in the market capitalization by 10%, right? So today we have seen an increase of the stock price by 10%. So one share of NVIDIA is now worth $1,409 at the time of recording. And you can also see like NVIDIA is now the fourth largest asset in the world. Okay, so why is that? Let's try to take a step back and understand NVIDIA. And in this video we are also going to learn about the newest big idea that has catapulted NVIDIA to one of the most relevant companies with one of the most interesting prospects in modern times. Okay, so what is NVIDIA all about? NVIDIA is about accelerated computing. This is a core idea of NVIDIA. Since they started accelerated computing, what does it mean? It is a new computing paradigm where you don't only have the CPU, CPU-based computing, so you have like serial computing. Maybe you have a quad core, so you have the single CPU consisting of 4 cores that actually do the computational work. And the GPU or accelerated computing means that you have the sequential computing, the CPU with multiple cores. You enrich it with thousands of parallel processing units packaged in a single GPU. So we have a graphical processing unit of highly parallelizable tasks. But not all tasks can be easily parallelized. For example, let's say computing a spreadsheet is a serial task in many cases. But matrix multiplication, which is a task very common in graphics or artificial intelligence, is a highly parallelizable task. So you have a single instruction on multiple data, SIMD, and you can perform this computation on in parallel on thousands of cores. And this type of accelerated computing here you see on the y-axis, you see the trillions of operations per second, and this is actually a logarithmic axis, right? So you have 100 trillions of operations. Here we have 1,000, 10,000, 100,000, 1 million operations per second. So you have a 10x in each step on the y-axis, and on x-axis you have not a logarithm but a linear axis. So if you have such a log linear plot and you have a line in this plot, this means exponential growth. And you can see this is not like a future predicted growth curve. This line is actually it's a historic line, historic improvement of operations per second of computational power. So you can see NVIDIA has basically single-handedly solved Moore's law. Moore's law is this law that you have a performance improvement every single year, like the performance relative to the cost improves exponentially every single year. But you see Moore's law is kind of flattening out. The CPU-based scaling of computation has actually flattened out in recent years, but NVIDIA has actually superseded the growth of Moore's law. So here in green we see the growth of accelerated computing. So accelerated computing is great. It's a great paradigm for highly parallelizable workloads. And here is another impressive graphic. If you don't have a log axis on the y-axis, but you just have a linear plot, so you don't have any log axis, then you see the improvement going from, say, the Pascal 19 teraflops FP16 to Volta to Ampere to Hopper, to the Hopper platform. These are actually the H100s. And basically, this is now interesting. Here I have annotated this. H100 are responsible for the breakout earnings we have seen today, or actually yesterday, right? This the Hopper architecture, this computational platform, this accelerated computing platform is responsible for the breakout earnings we have seen in recent quarters. Everything until now is like this, right? But Blackwell is the infrastructure they are already producing currently. And you see how it is much, much more powerful even than the H100 platform. So is Blackwell the blockbuster AI product? So basically, the answer is yes. Yeah. So we see here the Blackwell, the new GPU, new AI based or new accelerated computing hardware that is the most efficient in the world, basically. So we already see like other vendors like AMD or so providing some new chips that have the performance or actually exceed the performance of the H100, but the Blackwell is so much it just dominates in performance so much that if you would compare it with the newest platform of say AMD, it would just dwarf, right? It would just dwarf the platform. So NVIDIA is crushing the competition once again with the new Blackwell blockbuster AI product. So just in general, looking at this, NVIDIA. So what is the total addressable market of computing, right? So you should ask this question of accelerated computing. So let's have a look at generative AI. Currently, we have started maybe 1-2 years ago of mass producing large language models, and we have seen huge user bases, like hundreds of millions of users, using text to text, right? This traditional chat interface. So we have ChatGPT, text to text interface, and which is basically the most simple form of generative AI, right? And this already led to the surge of demand for NVIDIA chips. But now what we are seeing more and more, the trend is, even with the newest model of NVIDIA, the ChatGPT 4.0 model, which I have done 2 videos on the Finxter channel, so you can check those out. Just go to the Finxter channel. The 2 most recent videos are about the 4.0, the Omni model. This basically comprises of a model that is capable of not only text, but also image input and speech input. It is actually a multi-modality, and you can put in, for example, images and get out text, or you can put in images and text and get out text, or you can put in images and text and put out and get out images, right? So you can combine different input types, right? And generate different output types. But obviously, like an image is worth 1,000 words, right? Even in processing, like an image is 1,000 times 1,000 pixels, for example. So you have 1,000 times 1,000 million input signals. So it is like an image already is an orders of magnitude more complicated to process for a neural model or neural infrastructure than simple text. And a video is just an image over time, right? So you have multiple images in a certain time step. And speech is also like highly complex. You can do Fourier analysis, sorry about that, to get the speech, like to extract the speech, the information, the sinus waves, and then combine the sinus waves to do the like overlay the sinus waves to get the speech. So you can produce speech as well, which is kind of this more complicated approach. But you can already see that in the graphical processing unit, GPU, where it comes from, it is the GPUs, accelerated computing, are highly suitable for those kind of training and inference tasks. And we have only seen the beginning of inference even, and the beginning of training these complicated models. So I called the presentation, like I wanted to put this number 1 million X into the presentation, because Jensen Huang, the CEO of NVIDIA, actually argued that in the upcoming years, we will see a 1 million X of increase in compute demand, right? So this is like a huge increase in compute demand. We are just in the beginning of a huge market. And if the compute demand increases by 1 million X, this doesn't mean that NVIDIA increases revenue by 1 million X. But it could definitely be that NVIDIA like easily increases the revenue by 10X. Maybe the cost will significantly drop, right? By 100,000 X per compute. This would be already a huge achievement, right? If NVIDIA could reduce the cost by 100,000 X, as compared to today for AI compute. But if they reduce the cost by 100,000x per compute unit, but we million-x our compute demand, then we would still get a 10x of revenue. So NVIDIA revenue growth won't slow down in such a scenario, right? It will just explode from here on out. And I think with humanoid robots, self-driving cars, like the different robotics platforms, the multimodality of the newest chat models, right, in OpenAI's models, the demand for AI training at Meta to create the metaverse, right, to create three-dimensional spaces, the Omniverse platform of NVIDIA to simulate, for example, 3D simulations of factories, in real-time simulations of factories to improve the design of factories, for instance. These kind of workloads, they are highly demanding in terms of compute. So if we see such a thing, like a million-x, we will see significantly growth in the stock price, in my opinion. And this is not financial advice, obviously. So here again, we see the graphic that just supports this argument. Generative AI drives the demand from chip to data center scale. So NVIDIA started out as a chip company. They sold GPUs, right, like single chips to gamers. But the performance of those chips has just kept increasing and improving, and the training compute petaflops have actually scaled up here exponentially as well. And in recent years, we have even seen an acceleration of the growth curve, which is insane because we already had an exponential growth curve, but now with accelerated computing, we see this acceleration of the computing infrastructures. So the models like GPT-3, Microsoft's model GPT-2, the newest models, even the Llama 3 model recently, like Facebook has spent 40 billions for AI compute. I have also done a recent video on the Finxter channel. By the way, subscribe if you want to stay on top of those trends. Subscribe to the channel. You can just give us a like and subscribe. You can see how the scale for AI training increases exponentially in this chart. And it will continue to do so. Why? Because of the so-called AI scaling laws. So we can throw more compute and more data at those problems, at those training problems, and get better performance. There's no convergence in terms of performance. We keep improving the intelligence of those models, and thereby we improve the utility of those models. And in practice, this means we will see self-driving cars. We will see humanoid robots. We will see different kinds of robots that really automate our work, that create trillions of revenue for companies and trillions of value and shareholder values for various companies that use those kind of models to automate much of the work we are doing as humans. So those models becoming smarter actually create a huge real-world value. It's not like a hype that is just feeding from investors, right? It's not like investors in those companies like Meta and so on just pay for the chips and the hype will stop for some way. There could be a hype, obviously, but there's also a real utility behind that. The real utility in the real world. We create real shareholder value and real value for employees and for customers as well. Okay, here really quick we see that there's huge value. We see how many models actually improve on human capabilities. Here 100% would be the human baseline, and we see various models in various type of benchmarks keep outperforming human beings. There's some research showing that generative AI revenue drives like $460 billion per year very soon in terms of savings. It's a McKinsey report, I think. So I just added those slides to show that it is real, right? So the takeaway from here on is NVIDIA doesn't sell chips, they sell AI factories. They sell whole data centers now. This is their strategy they have outlined in the earnings call. This is actually what I wanted to, like the one takeaway I wanted you to have from this video, right? But we will see some more interesting stuff, so stay tuned. These AI factories, they provide end-to-end AI training and inference that is packaged in a single data center, right? So you get data in the AI factory. This is a whole data center. Now does the compute, the training, the inference, and gives you the tokens, the generated tokens. This AI factory, they package as one huge, massive product worth millions. Also priced at millions of USD, sometimes tens of millions of USD for this one product. They just sell the AI factory as a service. So for example, in this case, we have 32,000 GPUs. So this factory, for instance, would cost, I don't know, maybe $100 million or so. Now the question is, who buys the AI factories? Obviously, we have seen companies such as Meta announcing huge amounts of purchases. Tesla purchased a lot of NVIDIA GPUs this year. I think they even now have the largest cluster. Why? Because for training, they're self-driving cars, basically, so that for real-world AI tasks or AI applications that create real-world values. But now, this is a new thing. In the earnings report, they said they already have 7 AI customers, and those this new business strategy of selling a 7 AI will from zero will generate revenue in the high single-digit billions. I think they say. We will see it in a moment, right? So in Q1, NVIDIA worked with more than 100 customers building AI factories. So they already have a huge demand for their product, for their whole packaged AI factories. Each AI factory is consisting of tens of thousands of GPUs. And they have hundreds of customers that build those factories, right? Everybody wants to build their own AI factories. Why is that? For example, nation state 7 AI refers to a nation's capabilities to produce artificial intelligence using its own infrastructure, data, workforce, and business network. Yeah, okay, here we can see it. From nothing the previous year, we believe 7 AI revenue can approach the high single-digit billions this year. And this is mentioned in the earnings call by Kress, which is the CFO, I think, from NVIDIA. So the importance of AI has caught the attention of every nation. So what does it mean, every nation? For instance, Japan has invested 740 million in building 7 AI infrastructure. France has built the most powerful AI-based supercomputer. Italy has built a powerful NVIDIA cluster or AI factory to develop a large language model that is natively trained in Italian language. Why are they doing this? For many reasons: privacy, security, sovereignty, right? So they want to stay sovereign. These are nation states. They don't want to send their data to other nation states and lose sovereignty and independence, right? They want to keep this. They want to have privacy of their citizens. So they need to build the infrastructure in their own country. How many countries there are? 195 nations. And if each nation just spends $1 billion or so on NVIDIA AI factories, which is like a conservative assumption for like the scale of a nation, right? And the demand for many of actually all applications now require AI compute, then you see it could be already 195 billion of annual revenue, like just the total addressable market if with these kind of low assumptions. Some nations are obviously so big they could spend this on their own, right? So maybe a nation like the US could spend 195 billion on their own for NVIDIA AI factories. So the potential demand is massive and no nation can actually afford to stay behind in this trend. Much like no nation could afford to not build the internet infrastructure. So there's huge potential demand for those AI factories. And I think the main takeaway from the earnings report is the growth story just continues. We have seen the jump of 10% in the stock price. Why is that? Because here you see the revenue like jumping to 26 billion. This is just a quarterly revenue jumping to 26 billion. and their operating margin is 69%. This is like an insane, unheard of operating margin for companies. So for every $100 they get as revenue, they keep kind of $69, right? This is huge, and you see the increase in revenue, and we can expect this year to be one of the breakout years once more, for in the NVIDIA growth story continuing. Good. So I think this is the most important information I wanted to share from the earnings report. So the growth story continues. We have seen their focus on AI factories. Who are the customers of those AI factories? Huge corporations and nation states. And there's no end in sight, basically. If you want to stay on the right side of change, then check out the free Finxter email newsletter. Just go to finxter.com and subscribe to any of our email forms. I will keep you updated with AI news and the topics that are relevant to help you stay on the right side of change. If you want to scale up your knowledge, then check out our AI engineering courses on the academy.finxter.com. We have a lot of courses. You can browse the course library, basically all courses. It's like a Netflix for coders, right? So you subscribe, small annual fee, and you can access all courses. And the most recent courses are about multi-agent, building multi-agent teams and systems. We will soon launch this month, or maybe beginning of next month, we will launch a new course by one of our star creators, Dirk, on Hugging Face, how to use Hugging Face. I think this is very important for every AI engineer who wants to scale up their value proposition and their value offering in the marketplace. Okay, thanks for watching. I'm really grateful to have you here. By the way, you can also become a member by joining the Tech Guide HANA level or above. You can access all Academy courses using this. If you want to dive deeper into NVIDIA, then I would recommend you check out this video. I will give a link in the description below, the 10 modes of NVIDIA. Maybe I can also add a link in the description below, or somewhere on this YouTube page. Okay, thanks for watching, and see you in the next video. Bye.